Assalamu alaikum and welcome to this video. In this lesson, we'll talk about the relative measures of dispersion because in the last lesson, we saw that the absolute measures of dispersion, including range, variance, and standard deviation, had some limitations in terms of comparison between data sets which contained values on different scales, units. So for this reason, we need to have the relative measures of dispersion, but let's first understand what the problem is in case of the absolute measures of dispersion. It says that the absolute measures of dispersion are influenced by scale and units of the data values. And because of this, it limits the comparison between data sets, which vary in size, scale, and units. Let's see this data set one, which is the time in minutes taken by semester one students to write a piece of code for a certain simple task. And you can see the values here. We can see that 37 is the least value and 90 is the highest. And the values range between these 37 and 90 और इनकी जो वेरिएशन है वो भी आप यहाँ से देख सकते हैं. The standard deviation comes out to be 16.82. Then we have another data set in which we record the time in minutes taken by the semester 8 students who are better at programming than semester 1 theoretically to write the same piece of code. And you can see the times here, and we can identify that the least value is 9 and the highest value is 20, right? Okay, now the standard deviation comes out to be 3.95, and the question is, does it actually these two data sets actually have this much difference in the variation of values within each data set? We see that these values, and we see that the values are not very different from each other. And we see this set, and we again can see that the values are not very different from each other, although the difference is between the values is smaller in this data set as compared to the difference between values in this data set. But is it actually this much of a way of the difference between the measures of variance? 16.82 is about 5 times the variance or standard deviation of this data set. तो क्या इतना ही डिफरेंस आ रहा है दोनों के अंदर वेरिएंस का? तो आंसर एक्चुअली ये है कि बिकॉज द स्केल ऑफ वैल्यूज इज डिफरेंट इन बोथ ऑफ दीज डेटा सेट, उसकी वजह से ये जो मेजर्स हमारे पास आ रही है दे आर एक्चुअली इन्फ्लुएंस्ड बाय द स्केल. और क्योंकि ये लार्ज स्केल वैल्यूज को के ऊपर बेस कर रही है ये मेजर, तो उसकी मेजरमेंट की वैल्यू भी बड़ी है, और ये स्मॉल स्केल वैल्यूज के ऊपर है तो वो वैल्यू भी छोटी है. इसी तरीके से अगर हम इनको फर्दर इसको मैं कन्वर्ट कर दूं सेकंड्स के अंदर मिनट्स की बजाय, तो आप देखेंगे कि ये वैल्यू और ज्यादा बढ़ जाएगी. ये एग्जांपल आप खुद करके देख लीजिएगा. इफ यू convert all of these minute values into seconds and then calculate the standard deviation, you will find that the standard deviation for the same data set will now become very large when you change the unit of the measurement. So then we need the relative measures of dispersion. What did it do? They actually provide scale and unit agnostic measures of the data variability. They facilitate comparison between data sets which are different in size, unit, and scales. And these include coefficient of variation, coefficient of range, and coefficient of mean deviation, the one that we will be discussing in this course. The simplest one first is coefficient of range. It is the ratio between the difference of the extreme values to the sum of those values. Extreme se matlab, again, the least and the highest values. The ratio between the difference and the sum between these two values. So, and this is calculated by this expression, which is maximum highest value minus the minimum value divided by maximum plus the minimum. So just that. The difference between the highest and lowest divided by the sum of highest and lowest. That's it. This basically, when we calculate CR, because of this ratio, it cancels out the units and it neutralizes the scale because of this. So now we can we have a better representation of the variation, and the comparison becomes more fair. So here we have the same data set that we saw in the first slide. these two values on different scales. When we calculate the ranges, for the first one, we have 90, which is the highest value, minus 37, which is the lowest value, and we get 53. And we get the range as 11 in case of the second data set. And you can see that data set one seems to have a very high range if we just do the comparison based on range, the range only. But when we calculate the coefficient of range, which is the relative measure of dispersion here, and we use this expression, highest minus minimum plus highest plus divided by highest plus minimum, we get, for the first data set, we get the value as 0.4173. And for the second one, we get it as 0.3973. And you can see that when we convert them into percentages, you can see that there's very little difference between the two. So now we can compare the data sets better. So it's almost negligible kind of difference between the two, which appeared to be very huge when we first based it on the absolute measures of dispersion. Then we have the coefficient of variation, or CV in short, and it's one of the very popular relative measures of dispersion used. And it is simply calculated by this expression, which is the standard deviation of a set divided by the mean of that set. The units get cancelled out because of the ratio. The scale is neutralized because of the division by the mean. The size of the data set is neutralized because of the mean. We have n here in the calculation of S. We have n here in the calculation of X bar. And both of those cancel out. So all of these effects, they're actually eliminated from the calculation of CV. अच्छा एग्जाम्पल में देख लें डेटा सेट वन अगेन वही वाला है हमारे पास डेटा सेट टू भी वही वाला डेटा सेट है जब हमने इनकी कैलकुलेट की स्टैंडर्ड डेविएशन तो 16.82 थी जहां से बात शुरू हुई थी कि 16.82 और 3.95 आया था इतना बड़ा डिफरेंस नजर आ रहा था दोनों में फिर हमने उनकी मीन निकाली तो एक्स बार पहले डेटा सेट की आई 68.42 और दूसरे की आई 14.73 जब सीवी निकाला तो पहले का आया एस डिवाइडेड बाय एक्स बार पहले का आ गया 0.25 और दूसरे का आ गया 0.26 और हमने उसको परसेंटेजेस में कन्वर्ट कर लिया बिकॉज यूजुअली the coefficient of variation or coefficient of range and for that matter जो relative measures हैं dispersion की those are reported in terms of percentages तो आप देखें कि again we can see that the difference is negligible which appear to be that high in case of the absolute measures of dispersion. Then we have the coefficient of mean deviation. अच्छा इसमें थोड़ा सा हम जरा पहले समझेंगे इस टर्म को कॉफिशिएंट को जरा एक मिनट के लिए इग्नोर करें मीन डेविएशन क्या है उससे पहले क्या डेविएशन क्या है डेविएशन इज हाउ मच अवे ए वैल्यू इज फ्रॉम ए सेंट्रल वैल्यू ठीक है तो अगर मैं कहूँ मीन डेविएशन का तो मतलब है सारे डेविएशंस निकाली हर वैल्यू की डेविएशन निकाली फ्रॉम द सेंट्रल वैल्यू और उनको ऐड करके मैंने काउंट से डिवाइड कर दिया तो मुझे किस चीज की वैल्यू मिल गई मुझे मिल गई वैल्यू मीन डेविएशन ठीक है तो पहले मैंने डेविएशंस निकाली फ्रॉम द सेंट्रल वैल्यू फिर मैंने उनकी एवरेज ले ली तो आई गॉट मीन डेविएशन राइट अच्छा फिर कोफिशिएंट ऑफ मीन डेविएशन बेसिकली आएगा जो कि रिलेटिव मेजर है ऑफ मीन डेविएशन अब जरा अब इसको हम देख लेते हैं कि हम ये एक्सप्रेशंस निकलती कैसे हैं mean deviation is the average of the absolute differences between the values and the central value of the data set so the central value can be mean median or mode तो पहला इसमें तीन किस्म की चीजें आ सकती हैं क्योंकि सेंट्रल वैल्यू अगेन मीन मीडियन मॉड हो सकता है तो वी कैन हैव मीन डेविएशन फ्रॉम मीन वी कैन हैव मीन डेविएशन फ्रॉम मीडियन एंड वी कैन हैव मीन डेविएशन फ्रॉम मॉड और इसी तरीके से वी कैन हैव कोफिशिएंट ऑफ मीन डेविएशन फ्रॉम मीन वी कैन हैव कोफिशिएंट ऑफ मीन डेविएशन फ्रॉम मीडियन एंड कोफिशिएंट ऑफ मीन डेविएशन फ्रॉम मॉड तो अभी तक हमें ये चीज आपने देख ली होगी कि कॉफिशिएंट जहां पे लग रहा है जिस टर्म के साथ पहले कॉफिशिएंट का प्रीफिक्स आ रहा है वो बेसिकली आपकी रिलेटिव मेजर ऑफ डिस्पर्शन को बता रही है तो पहले देख लेते हैं जो मीन डेविएशन फ्रॉम मीन निकालने का तरीका अगर हमारे पास एक ये सिंपल सा डेटा सेट है एंड वी गॉट एक्स बार एज 3.875 and this is how we are going to calculate the mean deviation again this is absolute measure of the deviation absolute से मतलब है कि we are ignoring the sign ठीक है we only take the magnitude क्योंकि अगर हम साइन इग्नोर नहीं करेंगे और हम तमाम deviations को ऐड करेंगे तो for the normal distribution or for the symmetric distribution we will end up having zero when we add up all ठीक है because if we do not take the absolute of the deviations, or if we just simply add the deviations, including their signs, for symmetric population, we are going to get a value 0. ठीक है, तो यहाँ पे आप देख लें क्योंकि ये एब्सोल्यूट लगा हुआ है तो इस वजह से वी गेट ऑल द पॉजिटिव वैल्यूज. ये तमाम की तमाम डेविएशंस आ गई फ्रॉम द मीन एंड दिस इज द सम ऑफ ऑल द डेविएशन. When we divide it by the count to take the average of the deviation, which is mean deviation, yani ki average of the deviation, we get the value as 2.11. So for coefficient of mean deviation, we have mean deviation divided by x bar. The value comes out to be 0.544 and will be typically reported using the percentage. So it will be 54.4%. Then if we do the same for the median, we have the same data set and the median is 3.5. And the deviation from the median is this. Again, there's an absolute sign over here, so we are ignoring the sign of the values. Now, taking the mean or average of the deviations, it is, we add up all those of these deviations and we get the value 16.5, which we divide by 8 to get the average deviation, and that is 2.06. And then we, for the coefficient of mean deviation, we divide this mean deviation by x bar. Please note that we divided again. In case of mean deviation from median also, for the coefficient, we divided it by the x bar. And the value comes out to be 0.5893. Again, reported as 58.93. We can have mean deviation from mode also. We have the same data set. The mode is 3. We calculate the deviations, take the absolute values, calculate the sum of the deviations, and take the average, which is 2. For the coefficient of mean deviation, we have the mean deviation from mode and divided by x bar, and the value comes out to be 0.6667, which is 66.67, and that's it. So this is as simple as this. For the relative measures of dispersion, they make comparison between the data set fair and easy by neutralizing the effects of scale, size, and units.